Now, the concept of subcircuits is very crucial for the design of large-scale digital circuits. Basically, we can include a Verilog module as a subcircuit inside another module. Module provides a template from which you can create actual objects. When a module is invoked, Verilog creates a unique object from the template. The process of creating objects from a module template is called instantiation, and objects are called instances. So module instantiation, basically the representation of object-oriented programming in software. Syntax for module instantiation is kind of like the module declaration. It starts with a module name that's included in the parent module, followed by the user-defined instance name and the ports list associated with it. Let's take a practical situation where we can incorporate the idea of subcircuits in the design. A few slides back, we designed this 1-bit full adder block. This time we have to implement a 4-bit full adder circuit. So what we can do is that we can use this 1-bit full adder block as a subcircuit in 4 stages and implement the full design. So at stage 0, the 0th bits of A and B will be put to this block along with the input carry C in, and the 0th bit of the sum will be produced, which is denoted by S0, and an output carry will be produced. This output carry will serve as input carry to the next stage. This way, in 4 stages, all of the sum bits and the final output carry bit will be generated. Here, I have attached the Verilog code that will implement the 4-bit full adder circuit. Code for the 1-bit full add block is same as before. The full add 4 module, which is the parent module in this design, this full add module instantiated 4 times to implement the 4-bit full adder circuit. Please keep in mind to provide unique names for each instances, otherwise the Verilog compiler might show error. So far, we have encountered 2 basic data types, wire and read. There are some conventions in Verilog that restrict their uses in certain places. For example, if a variable is on the left-hand side of an assignment inside an always block, it must be declared as a read. However, outside the always block, during the continuous assignment, left-hand side variable must be a wire. Input and output ports are wires by default. Any of the output ports are assigned in an always block, it must be written as read using this format: output read and the variable name that. Now that we have some ideas about the basic register data type, I think it's worthwhile to mention 3 additional register data types, which are integer, real, and time data type. Integer data types can store both signed and unsigned integer values. The default size of an integer is 32 bits. Integers are mainly used as group variables in variable. Real data type can store numbers with fractional parts or specified in scientific notation, like 3 × 10 to the power 8 can also be stored in Verilog using this real data type. However, if real data is assigned to an integer, it will be rounded off to the nearest integer. Time is a special Verilog data type which can be used to store the current simulation time. In this slide, you can find the details of these 3 data types. Have a look and you will have a working knowledge of these data types. And that brings us to the end of this presentation. Verilog has extensive resources and it is almost impossible to cover all the basics in a single session like this one. However, I've tried my best to cover all the basic topics related to this course. If you want to go into deeper details, please feel free to check out the texts and references provided here, or you can contact us for any confusion. Thank you for your patience and time.